Hello, my name is Mark Stahl, and I'm Director of Recycling Products for Work in America. We appreciate the opportunity to spread knowledge about pavement recycling, and specifically today, I'm going to present on the Cold Central Plant Recycling Process, or CCPR. Well, let's jump right into it. Let's talk about the roadway system in the U.S. Our roads were typically designed decades ago, and even though they factored into the equation the amount of anticipated growth, I don't think anybody could accurately predict the volume increase or the higher percentage of truck traffic that we see today. We see traffic patterns like this, where in our urban settings, our pavements are becoming parking lots. Or we see situations like this, where of that traffic, we have a higher percentage of semi-traffic. Results, we have pavement conditions that look like this, where we see roads that are rehabilitated several times. We see rutting and base failures. We see pavements like this, where they're older pavements that have been oxidized and they're failing from the top down. Potholes, cracking. We see composite pavements, where concrete pavements deteriorate, and in order to address that, road owners will put a hot mix overlay on top of it. The concrete below keeps moving. Cracks come up from the bottom to the top of the hot mix layer, and we have pavements that look like this. So, taking in consideration the current state of our pavement system, recycling provides a lot of benefits in terms of trying to rehabilitate these aged, deteriorated pavements. So why should we concentrate on recycling? Well, it provides a lot of benefits to the road owners. First, we just acknowledge that most of our roadways are past the conventional overlay stage. Recycling produces flexible pavements that retard cracking. So recycled material is flexible. It will allow loads to go over it, but it remains flexible. So we don't see cracks propagate up from the bottom to the top. Recycling also reuses materials that are present. So they're already paid for once. They're valuable to the road owner. So we want to reuse them and leave them in place. Recycling makes maximum use of tight budgets. So typically, recycling processes cost 40% less than the traditional remove and replace techniques. It's a fast process, so there's shortened construction time frames. This translates to inconveniencing the traveling public, which is on the top of everybody's mind. And then lastly, it's a responsible construction practice. It is green. There's an animation of the CCPR process.
Pavement rehabilitation using the Wirtgen cold recycling process, a method for the complete rehabilitation of pavements in 5 steps. Mill off asphalt pavement. Pre-spread cement. Stabilize subgrade. Produce and pave base layer. Pave surfacing. In the following, our animation shows the sequence and individual process steps of the construction project. In the first step, the damaged asphalt pavement is milled off. A large milling machine from Vietgun removes the asphalt at full depth, loading the granulated material right into waiting trucks. Front loading permits quick truck changes. The milled material is transported to the KMA 220 mobile mixing plant set up in the vicinity of the construction site and unloaded for stockpiling. Cement is pre-spread for stabilization of the subgrade layer. A Streumaster binder spreader is used to precisely spread the cement via computer-controlled metering feeders. In the next step, the subgrade layer is stabilized. The operation is performed by a Vietgun recycler. The milling and mixing rotor mixes the material, pre-spread cement and added water to produce a homogeneous mixture. The stabilized layer is compacted by a single drum compactor from Ham, while a grader carries out finish grading. Final compaction is effected by tandem and pneumatic tired rollers. In the next step, the granulated material is recycled and placed again immediately after recycling. The material is processed by a Vietgun KMA 220 cold mixing plant. The stockpiled material is fed into the plant by means of a wheel loader. Cement is delivered to the plant from a stationary silo, while tanker trucks supply water and bitumen. The KMA 220 produces foamed bitumen by injecting precisely metered quantities of water and compressed air into the bitumen heated to 170 degrees centigrade. The integrated twin-shaft compulsory mixer mixes the materials in a continuous operation, producing around 200 tons of homogeneous mix per hour, which is conveyed into waiting trucks via a belt conveyor. Trucks return the mix to the construction site, where an asphalt paver from Vergler ensures paving true to line and level. Final compaction of the new base layer is carried out by tandem and pneumatic tired rollers from Ham. The asphalt surface course is applied in the final step of the operation. Final compaction is carried out by tandem rollers. Done. Traffic can flow again smoothly after an extremely short construction period. Reuse of material, saving of resources, short construction times, energy efficient, environmentally friendly, enormous cost savings, extended lifespan.
This cold central plant recycling process that you just saw an animation for is just another tool in the toolbox for road owners. Okay? It's not a one-size-fits-all process. So we need to evaluate the pavement, make sure it's a candidate for the process, but it allows the road owner to stretch funding or the number of miles that they can rehabilitate. It addresses the cause of the failure, not just the symptoms. Reutilizes the good material that's already paid for. And what's unique to the cold central plant process is we can use up to 100% RAP in this. And of that RAP, we can either utilize job site material or we can utilize a stockpile that maybe has been taken from other projects. So it gives the road owner some flexibility in terms of utilizing a high amount of RAP and then figuring out which source of RAP to use. Cold central plant is similar to the full depth recycling and cold in place recycling in that road evaluation is very important. We need to go out, drive the roads, evaluate the distresses that are present, and figure out, does cold central plant process work for this situation? If it does, then we take samples of the materials that are present. We want consistent pavement structure. So we'll take samples, we'll take that material back to a lab and perform mix design procedures. And the other thing that's nice about cold central plant is we can use emulsion or we can use foam with cement. So another flexible option. Some differences about cold central plant recycling is we can apply more engineering control to this process because, one, we are using material that are typically stockpiled, so we can check gradation, we can check quality, and then while we produce this material in the plant, we can take samples before it gets shipped to the job site. So allows for stepped up testing if desired. Another difference with the cold central plant process is there is increased trucking cost or transport cost because we're removing millions from a project and hauling it to a stockpile and then producing the material through a cold central plant and transporting the material back to the job site. There is increased trucking costs. And obviously there's a need for a material yard. So we need a lay down yard for our plant to process material. So these are the differences of cold central plant recycling as opposed to the other disciplines of recycling. Typical candidates of CCPR, it can be a 4-lane divided interstate. We can use the cold central plant on state routes, county highways. We can use it in rural farm to market roads that might have specific or isolated base failure areas. Or we can utilize it in private commercial lots such as this. And I think this is where there is a high potential for using this process on a regular basis. And I want to use the next slide as an example to show the economic benefits of using the cold central plant process in the commercial private lot setting. So in my example, I have a typical commercial lot design here where we have sub-base soils that are present. We have an 8-inch aggregate layer topped with 3 inches of hot mix asphalt. So when we do pavement design, it's all about the strength, and we put coefficients to each of these layers. So for the aggregate base layer, we have a structural coefficient of 0.13 multiplied by the depth of 8 inches, and that equals a strength number of 1.04 for that 8-inch aggregate layer. For the hot mix, obviously it's a stronger material or a higher strength material, so we have a coefficient of 0.44 multiplied by the 3-inch depth, and we get 1.32. So that pavement strength number equals 2.36. So let's conversely look at an alternative method. So we will use same sub-base soils are there, but because we're going to use a thinner pavement depth in total, we're going to use less excavation and less material moving, basically less material management. In this situation, we're going to use a 4-inch bituminous stabilized material used through our cold central plant, and we're going to top it off with 2 inches of hot mix asphalt. So let's see what the numbers look like for this. So in this situation, NCAT and other testing agencies have come up with a strength coefficient for cold central plant processed material of 0.39. So not quite as strong of a coefficient as hot mix asphalt, but pretty close. So 0.39 times 4 inches equals 1.56 for that 4-inch recycled layer. And then we have a 2-inch hot mix pavement on top of that. We have the same structural coefficient of 0.44 times 2 inches deep is 0.88. So when we add that up, we have a strength number of 2.44. even though it's 6-inch pavement with the alternative design, it's stronger than the 11-inch pavement design over here in the typical commercial lot design. So we see the strength number benefit to using less pavement in terms of depth, but utilizing recycled process for that strength gain. So obviously the data shows that this is a more efficient process. We don't have to excavate as much dirt, move materials around, less trucking, and this is just for the private commercial lot setting. So what we need to keep in mind when we're using recycled materials is we are just building and constructing a base layer. We still need to put a wearing course on top. We still need to either put a hot mix lift on top of that, a chip seal, or a slurry seal. Where is cold central plant being utilized? Well, we see Virginia as a leading state. In Virginia, we see the CCPR process being used on interstates and state routes. Same thing with West Virginia in terms of the state routes. In Indiana, Michigan, they typically use this process for county highways. And in California, New Jersey, and New York, they use it for commercial parking lots. So let's go through the process step by step. In the animation, it showed the first step is removing asphalt with a mill. And that's exactly what this is. We take that material back to a material yard and we crush it. We want to downsize those particles so that we can, basically go with a mixed design. Typical gradation is 1.5 inches minus. We screen that material or fractionate it if we want to use 2 different types of. And then we run that material through a cold central plant. And for this example, I'm going to use the Wirtgen KMA 220i. As you can see in this picture, it's a compact unit. It fits on one semi-trailer load, so it's convenient for hauling around, convenient for getting into tight material yards. Typically, cold central plants do not require permits. There are 2 factors for that. One, it's a cold process. We don't have a burner where we dry aggregates like in a hot mix plant, and we don't have a baghouse. So those 2 situations typically don't require permits. So the components of a central plant are as follows. First, we've got a 175 horsepower engine on our Wirtgen KMA plant. So it's self-powered. We don't need a generator and we don't need a electrical drop. It has a 1,200 gallon water tank on board. We have material hoppers where we introduce the wrap or aggregate. We have a cement auger, so when we use foam, we need to introduce 1% of cement into the material. We have an injection system for water, emulsion, or foam bitumen. We have a twin shaft pug mill mixer that mixes the additives along with that wrap for a homogeneous material. The control house allows the operator to input mix design information into the computer, and it's also a place where he can monitor the entire production system. And then lastly, we have a loading belt where the finished material is loaded into a tandem, or it can be put on the ground and made into a stockpile. Our material flow looks like this. We have the hoppers. There are 2 hoppers with a divider in the middle, so we can fractionate wrap, or we can use wrap and an aggregate blend. We have the conveyor that picks that material up. We have a belt scale that weighs the material. The cementitious or bituminous binding agent dosing is done there at the end of the belt, where the material is introduced into the twin shaft pug mill mixer. Material is mixed in the mixer and then loaded onto the loading belt, which delivers the material to a tandem or a semi for transport out to the job site. Typical cold central plant setup looks like this. Our yard here in this example is 130 foot by 130 foot, so pretty tight area. And you will see the cold central plant here. We have our ramps for our loader to introduce the wrap or the aggregate into the plant. We have a 5,000 gallon water tanker here. We have a vertical cement silo here, and our hot bitumen or emulsion tanker is here. Control house, and then our load out belt where the tandem will come under the belt, get loaded, and take the material out to the job site. So this is what we typically see. Obviously outside of this 130 foot by 130 foot area will be your wrap stockpiles or your aggregate stockpiles. So material loading. Here's an example of two different materials. We've got aggregate on the left and sand on the right. The material openings underneath the hopper allow us to do blends. So in this situation, we've got a 65% aggregate and a 35% sand mixture. So some common materials produced by the KMA, as I said earlier, we utilize 100% wrap in this, or it can be a wrap and a virgin aggregate blend. The KMA will also produce cement treated base material, or CTB, and it'll produce roller compacted concrete. So the customer has some flexibility in terms of the types of materials that this plant will produce. The KMA will also produce material utilizing either emulsion or foam bitumen. Here's a picture of what the typical KMA site setup looks like. You can see we're looking at the ramp for the loader to get up into the hoppers here. We have our control house where the operator controls the whole process. We have our vertical cement silo, our bitumen or emulsion tanker here, and the water tanker with a hose running to the plant here. The load-out belt loading produced material into the hopper or into the bed of the tandem. Another view of that. This tandem will haul the material out on the project where he dumps into the hopper of the paver, and the paver spreads and lays that material just like hot mix asphalt. What's important is to experiment and understand the roll down amounts during the compaction process. And surprisingly, it is similar to hot mix asphalt. So typically we see a 1/4 inch of compaction per inch of material laid. A view of the material behind the screed. The material being compacted with a dual vibratory roller. And a close-up. And as you can see, that material is compacted nicely. It's fine gradation. Like in this situation, it was a 1.5 inch minus material. And this is a picture of finished 6-inch foamed CCPR. So what's next? We suggest applying a fog seal at the rate of 0.05 to 0.07 gallons per square yard. Allow this to cure for 15-20 minutes so that it doesn't pick up on vehicle tires, and then open it up to traffic. And with CCPR, as with all recycled pavements, traffic helps knead that material, almost like dough. So open it up to traffic is a good thing. And then lastly, a wearing course is installed, whether that be the next day or 10 days from now. A wearing course needs to be installed, whether that be hot mix asphalt, a chip seal, or a slurry seal. Two projects I want to highlight that utilize the CCPR project or process is Interstate 81 in Virginia That project was done in 2011, so it's been 9 years, and we've got some really good data from that project. And then the Interstate 64 project that's ongoing. We'll highlight that as well. So I-81 in Virginia, 4-mile stretch. It utilized the full depth recycling process, the CIR process, and the cold central plant process. So this was a great project to see how recycling material would hold up to interstate traffic. The process was like this. With the passing lane, we removed 2 inches of asphalt and stockpiled that wrap. And then that material below that was cold in place recycled 4 inches with cement and foam. In the driving lane, we removed 10 inches and stockpiled that asphalt. We stabilized the subbase, so we took care of the base failures with 5% lime. We used that stockpiled wrap and installed a 6-inch cold central plant material. And then both lanes, both the passing lane and the driving lane, received a 2-inch intermediate binder lift and a 2-inch SMA surface course lift. So the work was performed in 2011, and in the summer of 2016, we were able to get 5 years worth of data and see how the pavement was performing. And during that 5 years, I-81 saw 10 million easels of traffic go over that material, go over that 4-mile section. And the outstanding results were 0.10 inches of rutting, which is a minuscule amount, and then it had a ride index of 44 inches per mile. So really great data, positive data that came back 5 years later. So this data gave VDOT the confidence to utilize this material, this process going forward. If it would hold up to the high volume of traffic that I-81 had, then it would hold up to anywhere else, really. So it gave VDOT a lot of confidence. This data came from VDOT and from Brian Diefendorfer. This kind of laid the foundation for being able to use this process on I-64. The I-64 project took place in Newport News, James City, and York counties. It was just over 7 miles in length in both directions, so that translated to 56 lane miles. In this section of I-64, typically see 3,000 plus trucks per day, so a high percentage of the traffic that is there is semi-traffic. And they wanted to add a travel lane and a shoulder, so expanding the width, reconstruct the existing lane miles, and it was about a $190 million project. The project scope of I-64 was construct a new travel lane and a 12-foot shoulder, utilizing cement-treated asphalt foundation, apply a cold central plant base on top of that, and then the 2 lifts of asphalt surface layers. On the reconstruction of the existing lanes, the scope was remove the existing concrete by rubblizing it and hauling it away, full depth recycle the material below the concrete, add a cold central plant base course layer to that, and then on top of that put the typical asphalt surface layers. So I-64, what they did was they figured in 30 to 50% cost savings by utilizing the pavement recycling processes. 50% less greenhouse gases would be emitted by using this as opposed to the traditional method. They were able to fix the deterioration causes rather than the symptoms. And lastly, it was going to be a quicker construction project, less downtime, less inconvenience for the traveling public. I-64, the data that came from that would that they projected they could use over 200,000 tons of wrap for the cold central plant process segment. And the cost savings would be about $10 million utilizing this process. All this data came from VDOT. All this comfort level with this process was laid with the I-81 project back in 2011. Significant cost savings. The cold central plant process in general, kind of in summary here, the benefits. Produces a flexible pavement that retards cracking. Allows engineering controls with material quality and consistency. So we're able to take a look at the material, we're able to test it ahead of it being installed on the project. Cold central plant utilizes job site material or stockpiled wrap. So it gives the flexibility to the road owner of what material they use. Contractor can use normal paving equipment. So if he's a hot mix paving contractor, he's already got the needed equipment. And cold central plant does not need permits typically because it's a cold process. So in summary, CCPR is just another tool in your recycling toolbox. It can be easily coupled with other recycling disciplines such as FDR and CIR. It's an adaptive process. It can be used at the DOT level, state level, city level, or private commercial lots. And it is a proven process that other states are utilizing. So it's not a new process. It's a process that's been around for decades, and we've got data to show results. I thank you for your attention.